This is Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. The today topic is the coefficient of restitution and recoil of the gun. Here we have considered the object having mass m, moving in linear directions with a velocity u as shown in figure. Let F1, F2, F3 are the forces which are acting on the body. Because of the influence of the forces, after time t seconds, it has attained a velocity of v as shown in figure and travelled a distance of s in meters. Now, if r is representing the resultant of all the forces, we can modify this equation as now r is equal to m into a now, where r is the representing resultant of system of forces which are acting in the direction of motions, and a is the acceleration which the body is moving, and so we can write it r is equal to m into a now. But a is the acceleration, it can be defined as the rate of change of velocity, hence we can write it r is equal to m into dv by dt now. The modified equation is r into dt is equal to m into dv now. The product of r into dt is called here the impulse, and m dv is representing the change in momentum of the body. Here the force is acting on the body when it is having initial velocity u as well as the final velocity v now. We are already assumed it is equal to t seconds, and the time, the distance travelled is taken here s in meters now. Hence, the total momentum possessed by the body, that is change in momentum from final velocity to initial velocity, is given by the difference of final momentum and initial momentum mv minus mu, but it should be equal to the integration of 0 to t r into d theta now. The product of r into theta from integration from 0 to t is called the impulse. The units are force, distance, force and time, hence it is Newton seconds. The m is nothing but the quantity possessed by the body in motions. Here we are calling it momentum. A change in momentum is equal to mv, that is the final momentum, and mu is the initial momentum, that is the impulse is equal to change in momentum. We can write it mv minus mu now. Since the force as well as the velocity both are vector quantity, hence the impulse as well as the momentum also the vector quantities now. If the resultant force acting on the body, when it is equal to 0, that is in these equations, if we take r into dt dash integration from 0 to d is equal to av minus mu. If the resultant force which is acting on the body is equal to 0, that means r is equal to 0, then we can say mv minus mu is equal to 0, or mv is equal to mu now. That means the momentum possessed by the bodies, finally, that is at b, it should be equal to the momentum possessed by the body at first position, that is when it is having velocity u now. Then we can say the momentum is conserved. That is, when the momentum is conserved means the resultant force acting on the system should be equal to 0 now. So it leads to the law of conservation of momentum. it states that the total momentum of two bodies remains constant after the collisions or any other mutual actions. Here in this case, the two bodies are we are taking now, which is having M1 is representing mass of the first body and U is representing the U1 is representing the initial velocity of the first body and U2 is representing the initial velocity of the second body and M2 is representing the mass of the second body. Both are moving in the same directions like this. Assume U1 is greater than U2. After some time, the collision is taking place and also they separated with certain distance now. So here the collision is taking place now. Here U1 is representing the initial velocity of the first body. It is having more than the initial velocity of the second body. Then only the collision is taking place now. But after the collisions now, V1 is representing the final velocity of the first body and V2 is representing the final velocity of the second body. In this case, here U2 is greater than the V2 is greater than the V1. Now, according to the law of conservation of momentum, the force that is involved in the collision process, if it is equal to 0, that is the momentum possessed by the bodies before the collision should be equal to the momentum possessed by the bodies after the collisions. That means M1 U1 plus M2 U2 is representing the momentum possessed by the bodies before the collisions, which should be equal to momentum possessed by the body after the collisions M1 V1 plus M2 V2 now. This is called the law of conservation of momentum. The total momentum of two bodies remains constant after their collisions or any other mutual actions and mathematically represented as M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2 now. This is called law of conservation of momentum. This law of conservation of momentum, it holds good when the resultant force acting on the system of bodies or on the system should be equal to 0 now. That impact. When the two bodies are colliding with each other, then they are said to be having an impact. So the process is taking place. Here it is nothing but representing M1, here M2, U1 and U2 moving in the line of directions as shown in figure. In this case, U1 and U2 are representing the initial velocity of the two bodies. U1 is greater than U2. After some time, they are nothing but here collision is taking place and afterwards here they separated with certain velocity later now. Here the time taken the bodies, two bodies, here in the collision process, first of all the two bodies having different velocities and according to this figure, the body which is having mass M1 is having more in velocity U1. While colliding, these two bodies compressed and after maximum compression, they regain its original shape and they separated with certain velocities. We have taken V1 and V2 are representing the velocity of separation. The amount of time required for the compression of the two bodies in a colliding process is known as time of compression. Similarly, after the compressions, the two bodies are regaining its original shape and they are separating now. The process of regaining its original shape is called restitution. The amount of time taken by the two bodies to regain its original shape is called time of restitution now. The sum of the time of compression and the time of restitution is called time of collisions. Sometimes it is also called period of collisions and sometimes it is also called period of impact. Newton's law of collision of elastic bodies. When the two bodies collide with each other, the velocity of separations, that is V2 minus V1, is always behaves a constant ratio with the velocity of approach. That means if V2, V1 is representing the final velocity of the two bodies after the collisions and U1, U2 are representing the initial velocity of the two bodies before the collisions, then velocity of approach is given by U1 minus U2. After the collisions, V2 is having more in values, hence velocity of separation is given by V2 minus V1. According to the Newton's law of collisions, the velocity of separation, that means V2 minus V1, behaves a constant ratio with the velocity of approach, that is E is equal to U1 minus U2 now. Where E is called here now, it is a proportional constant, but it is also called coefficient of restitution. Here considering the two bodies now, M1 and M2, both are moving in the linear direction as shown in figure, and U1 and U2 representing the initial velocity of the two bodies before the impact. During the impact, the two bodies compressed, and after this maximum extent of compression, they regain their original shape and separated. They will move in the same line of directions as them with the velocities of V1 and V2 as shown in figure. If the centers of the line which is passing through the center of two bodies and point of contact, if it is passing through the same line, the type of impact is called linear impact. Assume that two bodies before the collisions as well as after the collisions, they are moving in the same line or the line of impact. Now, according to the conservation of momentum, the momentum possessed by the two bodies before the collision should be equal to the momentum possessed by the bodies after the collisions. And according to the Newton's law of collisions, the velocity of separations, that is V2 minus V1, it behaves a constant ratio with the velocity of approach, that is U1 minus U2. Already told, E is representing the constant of proportionality. Generally, it is the coefficient of restitution. This coefficient of restitution values, it varies from 0 to 1 now. If it is having 0 values, then the two bodies said to be inelastic, and if it is equal to 1, the two bodies are said to be perfect elastic. But for the most of the bodies, it lies between 0 and 1 only. Types of collisions now. Here broadly the collision of two bodies taking place in two types. One is a direct impact, the second one is indirect impact. Sometimes it is also called oblique impact. The direct impact means the line which is passing through the two centers of collide bodies C1 and C2, it also passes through the point of impact. Here, according to this figure, I am taking this is known as a P is representing point of impact now. That is the line joining C1 and C2. If it is a pass through point P, that is a point of impact, then the type of collisions are called direct impact. If it is not passes through that point P, then it is called indirect impact. Sometimes it is also called oblique impact. In direct collision of two bodies, the line of impact of two colliding bodies is the line joining the center of these two bodies and passes through the point of contact or point of collision as shown in figure now. Now consider the bodies A and B having masses m1 and m2, moving initial velocity u1 and u2. After the collisions, they are separated with the velocity of v1 and v2 as shown in figure now. Then, according to the law of conservation of momentum, the momentum possessed by the two bodies before the collisions should be equal to the momentum possessed by the after the collisions. That means the law of conservation of momentum, it holds good for the direct impact or direct collisions problems. Indirect impact of two bodies now. The line joining the centers of two bodies during the collisions, if it is not passed through the point of impact, then the type of collisions are called here indirect impact. In indirect impact, assume M1 and M2 are the two bodies moving initial velocity u1 and u2 as shown in figure. In indirect impact means the line joining the centers of two collide bodies C1 and C2 should not pass through the point of impact. So u1 and u2 are making that initial velocity of the two bodies are making an inclination of alpha 1 and alpha 2 with the line of impact as shown in figure. After the impact, they are having velocities in v1 and v2, making inclination of theta 1 and theta 2 with the line impact as shown in figure now. So in this case, since u1 and u2 and v1 and v2 velocities, these are the velocity of the bodies before the collision and after the collisions. Resolve these velocities into two components. One is along the line of impact and another one is perpendicular to the line of impact. So the component of velocities which are in line of impact before the collisions are here. The u1 is there when I am drawing vector representation. Here it can be represented as un cos alpha 1. It is moving toward the right hand side. It is in the direction of line impact, and u1 sin alpha 1, it is perpendicular to the line of impact. Similarly, for the second body, u2 is the initial velocity before the collisions, making an inclination of alpha 2 with the line of impact as shown in figure. Then when it is resolved into two components, that is u2 cos alpha 2, it is in the direction of line of impact, and u2 sin alpha 2 is in the direction of perpendicular to the direction of line impact. These are the component of velocities of the two bodies m1 and m2 before the collisions. After the collisions, the bodies are moving with the velocity of v1 and v2. The component of velocity along the line of impact after the collisions for the first body is given by, again, resolve the V1 into two components. The line of impact component is V1 cos theta 1. Similarly, for the second body, V2 cos theta 2, and the component of velocity is perpendicular to the line of impact after the collision. For the first body is V1 sin theta 1, for the second one is V2 sin theta 2 now. Now, when the bodies are collide with each other in indirect, the momentum of the bodies only conserved in line of impact directions. That means the component of velocities u1, u2, v1 and v2 along the line of impact will cause the direct impact, and all the relation for the direct impact holds good for these components also. All the relations means one is the law of conservation of momentum, that is the momentum possessed the bodies in the direction of line of impact before the collision should be equal to the momentum possessed by the bodies after the collision in the direction of line of impact. Similarly, the Newton's law of collision is also taking place, that is the velocity of separation, that is v2 cos theta 2 minus, that is, and v2 cos theta 1, that is the separations holds good a constant ratio with the velocity of approach in the same directions. That is, these two laws are holds good only for the direction of line of impact, and the momentum of the bodies perpendicular to the line of impact, it will not be changed after the collisions. Hence, the initial momentum possessed by the body before the collision should be equal to the momentum possessed by the body after the collisions. That means the movement is not at all playing any key role in the collisions which is in a perpendicular to the line of impact now. Hence, we are considering the only the component of velocities in the direction of line of impact. That is, E1 cos alpha 1 is representing the component of initial velocity of the first body along the line of impact. Similarly, U2 cos alpha is representing the initial velocity of the second body. Similarly, V1 cos theta 1 is representing the component of final velocity of the first body after the collisions. And V2 cos theta is representing the component of final velocity of the body after the collision. That means, according to the law of conservation of momentum, the momentum possessed by the bodies before the collisions in the direction of line of impact is given by m1 u1 cos alpha 1 plus m2 u2 cos alpha 2 should be equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2 now. And according to the Newton's law of collision of elastic body, the velocity of separation always be a constant ratio with the velocity of approach. Hence, v2 cos theta 2 minus v1 cos theta 1 is equal to E into v1 cos alpha 1 minus v2 cos alpha 2 now. Okay, recoil of the gun now. It is a work done based on Newton's third law of motion now. That is, the action and reactions both are equal in magnitude and acts in opposite directions. It is also applicable to the gun now. When the bullet is fired from the gun is always moves in opposite directions in which the bullet is traveling. This phenomenon is called recoil of the gun. Okay, in this case now, let M is representing the mass of the gun now, capital M. Capital V is representing the velocity of the gun, and small m is representing the the velocity of the bullet, and small v is representing the velocity of the bullet after the explosion, and capital U is representing the initial velocity of the gun, and small u representing the initial velocity of the bullet. That is, we are now taking here now capital M is representing the mass of the gun, initial velocity is u, final velocity is equal to v we are taking now. Similarly, for the bullet, small m is representing the mass of the bullet, and v is representing the representing initial velocity of the bullet, and small v is representing u, and small v representing the final velocity of the bullet. That is after firing. Since here now the law of conservational momentum is also holds good for this gun, the momentum possessed by the bullet and gun before firing is equal to, since the velocity is equal to 0, it should be equal to the momentum possessed by the bodies after the collisions. That is, I can take m into v minus m into v, it should be equal to 0 now. Here, since the momentum, that is the velocity of the gun, is in opposite directions in which the bullet is firing, hence one is taken now, we can take it as mv is equal to m into v now. That is, the momentum possessed by the gun should be equal to the momentum possessed by the bullet. Since the mass of the gun is very, very long now, very more, hence the velocity with which is moving in backward directions is compared to the lower values. The impact, that is the phenomena of the gun which is moving in backward directions when the bullet is fired, it is called recoil of the gun, which is given by here now capital M into V is equal to small into M into V now, where capital M is representing the mass of the gun and the capital V is representing the velocity with which the gun is moving in backward directions, which is should be equal to the m into mass of the bullet, and small v is representing the velocity of the bullet which is fired. These relations also properly known as law of conservational momentum, that is the momentum possessed by the bodies before the collision should be equal to the momentum possessed by the bodies after the collisions now. Okay, based on recoil of the gun, so we are taking two problems now. A machine gun of mass 25 kg fires a bullet of mass 30 grams with a velocity of 250 meters per second. Find the velocity with which the machine gun will recoil. So the given content within the problem is the mass of the machine gun is given capital M, it is given 25 kg. The mass of the bullet 30 grams. So converted the 30 grams into kg, which is equal to 0.03 kg. The velocity of firing is equal to 250 meters per second is given. So according to the law of conservation of momentum, the momentum possessed by the two bodies before the collision should be equal to the momentum possessed by the body after the collisions also. But here the gun is moving in opposite direction in which the bullet is firing. Hence, the momentum possessed by the gun should be equal to the momentum possessed by the bullet also now. So, which is equal to 25 into V is equal to, that is the momentum possessed by the gun, the mass into velocity should be equal to the momentum possessed by the bullet 0.03 is representing the mass of the bullet. Velocity is given by 250, which is equal to 7.5, or the velocity is equal to 7.5 divided by 0.3, which is equal to 25 meter per second. That means the gun recoil with a velocity of 25 meters per second. Okay, in the second problem, a bullet of mass 20 grams is fired horizontally with a velocity of 300 meters per second from a gun carried in a carriage, which together with the gun has a mass of 100 kg. The resistance to the sliding on the carriage over the ice on which it rests is 20 newtons. Find the velocity with which the gun is recoil, the distance in which it comes to rest, and time taken to do so now. Okay, in these problems, the mass of the bullet is given 20 grams now, which is equal to 0.02 kg. The velocity of the bullet is given 300 meters per second now. Mass of the carriage with the gun is given 100 kg. And the resistance to sliding is given here, F is equal to 20 newtons. So first of all, we have to determine the velocity with which the gun is recoil. Here, according to this problem, V is equal to velocity with which the gun will recoil. We know that the momentum possessed by the gun should be equal to the momentum possessed by the bullet. Hence, M into V is equal to M into V now, where capital M is equal to 100 kg into capital V, it should be equal to small m is representing the mass of the bullet, which is equal to 0.02 kg. Velocity is given 300 meters per second now. Hence, velocity is equal to, we can take it 6 by 100, or is equal to 0.06 meters per second. The distance in which the gun comes to rest. Since the initial velocity of the gun is equal to 0.06, we have to take it. But after traveling back certain distance, it is coming to the rest. Hence, the final velocity of the gun, it now becomes, since it is becoming, that is coming to the rest, hence it should be taken as 0 only. If A is representing the retardation of the gun now, and S is equal to the distance moved by the gun before coming to the rest, then we know that F is equal to M into A, where F is nothing but representing the resistance offered by the carriage to the gun when it is sliding over it now, which should be equal to M into A, where M is the mass of the gun, A is equal to the acceleration with which it is retarding now, that is retardations. So from this relationship we got to 20 is equal to M into A, M is equal to 100 into A, or A is equal to 20 by 100, which is equal to 0.2 meters per second. That means from this relationship we can determine the retardations. In order to know the distance it is travelled before coming to the rest, we can use the equations V square minus U square is equal to 2AS now, where V is representing the final velocity of the gun, but it is equal to 0 because it is coming to the rest now, and U is representing initial velocity of the gun, it is given 0.06 now. So 2AS, where A is representing the accelerations with which it is moving, since the final velocity becoming 0, this acceleration is treated as retardation now. S is equal to the distance travelled by the gun before coming to the rest now. So by applying all the content now, V square is equal to 0 is equal to U square, that is 0.06 whole square, minus 2AS, since A is in the retardations now, we have taken it as a negative sign now. From this relation, S is equal to 0.0036 divided by 4, which is equal to 0.009 meters or 9 mm. That means it travels in backward directions a distance of 9 meters before coming to the rest now. The second bit, the time taken by the gun in coming to the rest is given by, we can take by using the equations V is equal to U plus AT. In these equations, where is representing the final velocity of the gun now? U is equal to initial velocity, A is the accelerations, T is nothing but time taken by the gun in coming rest. Since the final velocity is equal to 0 because it is coming to the rest, U is equal to 0.06, the velocity with which it started to move in backward directions. So, by applying these equations, 0 is equal to, you can take it as a 0.06. Here, the acceleration is here negative because the retardation is taking place now. Hence, the value is also given, which is equal to 0.2 into t. So, on substituting these values in these equations now, we got t is equal to 0.06 divided by 0.2, which is equal to 0.3 seconds now. So, this is the time required to the gun for coming to the rest. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.